Till now, what we have understood is we have understood how to convert a binary number to a decimal number or any of the number system that is available to you. You can convert it to a decimal number by using the formula that I have in we have discussed in previous video. Now, in this particular video, what we will going to start is how we can convert a decimal number into binary, or how we can convert any decimal number to any of the number system given to you by just using the base of that particular number. Now, when we talk about the decimal to binary conversion, what do we have to look? We have to look that the base of the binary number system is 2. So what we will do that, we will divide that given number, given decimal number by 2, and we will see how it can be done. Right? So suppose we have a decimal number that is 13. So what we need to do, we need to divide the 13 by 2. So once we divide the 13 by 2, we'll go up to 6. To 6 are 12. 1 is the remainder. So we'll write the remainder as in LSB. And then the remainder, that is 6, will be divided by 2 again. So the resultant is 3 and remainder is 0. So we'll write 0 along with 1. Then we'll divide 3 by 2. So that we need to divide until we'll get the 0, either 0 as the remainder or 1 as the remainder. That at that time we need to stop. So now as we can see that we have divided 13 by 2 for 3 times, and we got the remainders as 1, 0, 1 and 1. Right? So whatever is the remainder is left, that is 1, 1, 0, 1. So this is the code for 13. You could have also done this by using place value method that I have told you. You need to you need to convert this decimal number of 13 into binary. So what you could have done, that use the place value of 1248. So we know that if I'll make this high, so we'll use this 8. If I'll make 4 also high, so 8 plus 4 is 12. I need to make 2 0 and 1 is high. So 1 0 1 is the 13. 8 plus 12 and 12 plus 1 13. So similarly, you could have done this by using a place value method itself. Otherwise, you can use this division method. If you need to convert this decimal number binary into an octal number, so in that case, what you need to do, you need to divide this octal number, this decimal number by 8, because the base of that particular octal number is 8. So we need to divide it by base of that number. So we need to divide by 8, and when we divide 8 1 8, 4 for 1 time. So the resultant is 1. And what is the remainder? The remainder will be 5. Right? So if 5 is the remainder and 1 is also there, so what should be the answer? Your answer will be 1 5. So that is your conversion into an octal number. Right? Otherwise, what you could have done, you could have used the direct conversion of this binary to octal. In that case, you need to make group of 3. We'll see how that we get done. So this is the code for 5, and this is the code for 1. Obviously, because if it is only single number is there, so we'll add 2 zeros here. This is the code for 1. This is the code for 5. So we can directly convert any binary number to octal number by making pair of three digits. Okay. So these are the two methods through which you can convert any decimal number to binary number, either by dividing it by the 2, by the base of that particular number system, or you can just use the place value method. So you can practice for that. You can pause the video and you can do the practice that how we can convert this decimal number 11 into binary. It is not a binary number, it is not 1, it is 11. That is given in decimals, so we need to convert it. So you can divide by 2 and you can get the result that 1011, or you can either use the place value method. So 8 plus 2 plus 1 is 11. So you can directly use the place value method, or you can divide by 2. So what you need to do is you need to divide 11 by 2. Once you divide 11 by 2, it will go up 5 times. So 5 and 10, remainder is 1. So what you will do, you will write 5 here, and remainder you can write here. Again, you need to divide 5 by 2. So once you divide 5 by 2, it will go up to 4 times, or 2 times, 2 is 4. Again, remainder is 1. So you will just write 1 here. Again, you will divide by 2. You go 1 times, 2 1 2. 1 is the remainder and 0 is the answer. So what you will do, you will write 0 here and 1 here. 1 0 1 1 will be your answer. Similarly, you can divide decimal number 4 into binary. and you can convert decimal number 17 into binary by using the either the place value method or division method. Similarly, you can divide this, then you can get the results. Now, what are the devices that we use to convert these number system in real time or real application, like when we use our digital devices, and how our digital devices convert if given number is in decimal, or how they can convert it binary or the required number format. So the devices that we use to convert are encoders and decoders. These encoders, what they do, they translate from decimal to binary, and for decoders, they do the conversion from binary to decimal. These are the general devices that are available, and you can have an example of that. If you will provide any decimal, it will directly given as the output in the binary form. Suppose if any decimal number is 0 is there, so you will get the binary output that is 0000. And if any another number of 5 is there, then you will get the output as 010. Similarly, whatever number you will hear, either 7, so you will get the result for 7, or if you press 3, you will get the result in binary form. So these are the encoders through which you can convert any decimal number to binary number in physical form. And these encoders are available in IC form. That's why when we use a digital to analog converter or analog to digital converter, we always use such kind of devices. These encoders we can use to convert any decimal number to binary or any binary number to decimal. For that purpose, we use decoders. Okay. So these are this is the example of any decoder, that if you have any binary number and you want to convert it to a decimal number. So what you can do, you can use a 7-segment display to display the number, and you will provide the data, you will provide the input in binary form, and that 7-segment display will display the output in a decimal number. Like you have seen in the traffic lights, or when you visit railway platform or any airport, you always see a display board. There, those display board always use 7-segment display, because the devices that are displaying those numbers, they all are digital devices, right? We use digital devices to reduce the cost, and we also use them to reduce the power consumption. So they are very cheap, they are very low cost and low maintenance sort of devices, all the digital devices. That's why we use them. And they are much more reliable and much more durable as compared to analog devices. And there's no problem of fluctuation, and a lot of things are very positive in the case of digital devices. That's why we use them. But we need to display the number in digital form, because decimal form. Why? Because it is not possible for people to understand the binary language. So if I want to display 10, so I should use 10 only. I cannot display 1010. Because those who have studied this binary number system, they only can understand. But people in India or in the world, they are more familiar with decimal number system. That's why we need to convert those binary number into decimal number. So if it is a number 0000, so we can display using the 7-segment display. In this 7-segment display, we have 7 LEDs connected in a systematic fashion. So they can represent any sort of number and any word of any letter of English language. So we have A, B, C, D, E, F, and G. So these 8 pins we have. So if I want to display a 0, then I can use all the LEDs except G to display a 0 number. Suppose if I want to display another number, that is 1. So what I should do, I should glow only B and C LEDs, and rest of the LEDs will be 0. It will be at 0 voltage, so they won't be glowing, and the resultant will be number 1. So suppose if I want to display 2, so what can I do? I can just glow A, B, G, E, and F LEDs, and rest of the LEDs, F and C, will be turned off. So similarly, you can display any number you want. You can display 3, you can display 4, or whatever number you want to display, you can do that. So these are the electron decoders. They are also available in IC form, and you can use that for binary to decimal conversion. Or if you want to show any decimal number, you can use that, and you can display this number using binary numbers. Right? So now, as we have studied about binary number system and decimal number system, there is another number system that is very popular, that is 16 hexadecimal number system. As this is hexadecimal number system, that means the base will be 16. And if the base is 16, that means we have the symbols in this particular numbers will be from 0 to 15. Now, to eradicate the confusion or mitigate the confusion among people that whether if I want to write 10 in this particular number system, so either I can use 10. If I use 10, then what will be the problem? Uh, you may confuse that it is 10 or 10. So to remove that confusion, what we did, we replaced the symbol 10 with A. So 10 is actually replaced with A, and 11 is B, C is actually 12, D is 13, E is 14, and F is 15. So we need to create a symbol for all these numbers in hexadecimal number system. So until 9, we have used the same number system the same symbol that we use in decimal. But after that, to remove the confusion, what we did, we replaced 10 and 11, 12, 13, 14 with the ASCII number, that is A, B, C, D, E, F. Okay. So the concept is same. If you want to convert any decimal number to hexadecimal number, what you can do up to 9, we need not do anything, and we can directly use that. And if it is more than 16, right? So if it is a 16 or more than 16, then it cannot be represented in hexadecimal form. So we need to divide by 16 and we can get the result. But in the case of binary, it is very easy for you to represent. And in hexadecimal, you need to divide by 16 for that. So up to now, up to 15, we know that it can be converted directly, it can be presented directly by F. But 16 is not an hexadecimal number because in hexadecimal, we have up to 15 only. So 16 is not the hexadecimal number. So to convert 16 into hexadecimal, what you will do, divide this 16 by 16. So obviously, when you divide by 16 by 16, the resultant will be 1 and remainder is 0, right? So your conversion will be 1 0, right? Similarly, if it is 17, your conversion will be 1 2 and 1 1. And similarly, you can convert any number, any decimal number into hexadecimal by dividing by 16. Or if it is a hexadecimal number and you want to convert into decimal, so you can use the same method that I told you. Either you can use place value method or you can use that formula that we have shared in the discussed in the last presentation. So hexadecimal to binary conversion, it is easy. As I have told you how to convert a binary number to octal number, you make group of 3. Similarly, in hexadecimal, what you do, you make group of 4, right? So C can be represented, C is 10, so you can directly convert it to binary, that is 1 0 0, and 3 is 0 0 1. So if any hexadecimal number is given, you can directly convert to binary codes. You remove the codes, you can use the place value method. And if you have any binary number and you want to convert it to hexadecimal, what you should do, you should make pair of 4s. So any number which is given to you, just make pair of 4s. If by making, we should make pair of 4s from the LSB. So this side is LSB. We should always start from LSB side and we should go up to MSB side. Suppose if you are making pairs, suppose this is the number given to you 1 1 0 1 0 1. So suppose this is the number given to you, a binary number, and you want to convert it to a decimal form. Then what you hexadecimal form. Then what you should do, you should make pair of 4s. So we have started making pair of 4s. This is the code for 5. You do that right. So you can directly write it. And what is the pair? Only 2 digits are left. So what you can do, make a pair of 4. You can add 2 zeros here. So once you add 2 zeros here, you can make a group of 4 again. And it is the code for 3. So this is 3, 5 in hexadecimal. Right? Similarly, the same process that I have told you, if you want to convert any decimal number to hexadecimal, and divide by 16, and you can get the results. So if you want to convert a 47 to a decimal number, hexadecimal number, so what you can do, you can divide by 16 and get the. Similarly, it is for hexadecimal to decimal conversion. It is also easy. What you can do, you can just either use the place value method or you can use that formula that I have told you. In this place value method, you just put the values here and you can get the results. This is the formula that I have told you. What you need to do, you need to multiply with the power of 16. So it is 11 here, B is 11, so 11 will be multiplied 16 power 0, 13 will be multiplied by 16 power 1, and 2 will be multiplied by 16 power 2. 16 power 2 is 256. We'll add these values and you can get the results back. That is 731. The 731 is the decimal number of conversion from 2 dB of hexadecimal. You can do the practice here if you want to convert A6 to binary. So what you can do, you can just pause the video and solve it on your own, and later you can see. So this is the binary number. Binary conversion, you just replace the codes. That A is 10, so you can add similarly for 6 you can add. Right. So similarly, this is what we did for hexadecimal. According to that, you can also do this for an octal number. So in octal we have 8 symbols, and those are the 8 symbols 0 to 7. So you can replace the decimal number to binary very easy. And if you want to convert it to octal, then just do it to 7, and for 8, you need to divide by 8. 8 onwards, right? You can also practice this here. You can use a scientific calculator. Most of the scientific calculators have this kind of concept that you can directly convert any number system, and you can use that. Thank you. This is that is all for this particular video. We'll study further in next video.